So last section of the chapter 3.8. We're going to talk about parallel and perpendicular lines with coordinates. Because some special things happen with the slopes of parallel lines and perpendicular lines. All right, our first key piece of information. If we think of a pair of parallel lines, so I'll draw. There are a couple of parallel lines. How are their slopes related? They have to be the same. Parallel lines have equal slopes. If the slopes were not equal, then one would be slanted differently than the other, and eventually they would touch each other. So parallel lines have equal slopes. That's our first key piece of information. So a couple of kinds of problems that typically show up having to do with parallel lines when we're talking about equations and coordinates. Similar to our opener, so we might be asked, are the lines through -3, -5, and 1, 3, and 2, -2, and 5, 4, parallel? So what this question is not asking us to do is not asking us to plot these points and make a line between them and then just look at it and say, oh, it kind of looks parallel or it doesn't really look parallel. What questions like this are asking us to do is compare the slopes. So I'm going to call this top one L1 and the bottom one L2. And I'm going to label my points, x1, y1, x2, y2. Doesn't matter which pair is 1 or which pair is 2, but the 1s have to stay in the same parentheses and the 2 have to stay in the same parentheses. And I'll do the same thing for the bottom ones, x1, y1, x2, y2. And we're going to calculate the slopes. So for L1, I get the slope is y2 minus y1, 3 minus -5, over x2 minus x1, 1 minus -3. So we get 3 minus -5 is 8, 1 minus -3 is 4, and my slope is 2. And if you want, it's fine to think of that as 2 over 1. We can always think of a whole number as a fraction with 1 as the denominator. And for L2, the slope is y2 minus y1, 4 minus -2, over x2 minus x1, 5 minus 2, 4 minus -2 is 6, 5 minus 2 is 3, and my slope is 2. And we can think of that as 2 over 1. They're exactly the same, so the lines are parallel. If they were not exactly the same, if one was 2.1 and the other was 2, those lines would not be parallel. They have to be exactly the same for the slopes to be parallel, or for the lines to be parallel. All right, questions there? Okay. The other kind of question that you might be asked with parallel lines is we want to find the equation of the line parallel to y equals 4x minus 2 that goes through -2, -2. So we want an equation of the line. We want it to go through a specific point. Well, what is the slope of y equals 4x minus 2? 4. So we want the slope of our new line is also 4. The slopes have to be the same. And this is my point that we wanted to go through, x1, y1. So I can use my point slope form to write the equation. Y minus negative 2 equals a slope 4 times x minus negative 2. And I can write that as y plus 2 equals 4 times x plus 2. If I wanted to rearrange this into slope-intercept form, I would distribute here. This is fine for an equation of the line. You don't have to do anything else. But you could distribute there, and I get y plus 2 equals 4x plus 8. And subtract 2, y equals 4x plus 6. So there would be the y equals mx plus b form. And we can see that the lines, the slopes of the two lines, they're both 4. This one has a y-intercept of 6. This one has a y-intercept of negative 2. All right, questions there? All right, the next key piece of information. The slopes of perpendicular lines. Anybody remember how the slopes of perpendicular lines are related? Slopes of perpendicular lines are negative or opposite reciprocals. And what we mean by negative or opposite reciprocals. If we have 1/2, what we do is we flip the fraction and we change the sign. Negative 2 over 1. Negative 1/2 and 1/2 and negative 2 over 1 are negative reciprocals. If we had negative 7/2, the negative reciprocal of this, flip the fraction, change the sign from negative to positive. If we just had 4, we can think of that as 4 over 1, and the negative reciprocal of that is negative 1/4. Flip the fraction, change the sign. So that's what we mean by negative reciprocal. So now we can kind of expand the kind of question that we might have about lines. But these are similar kinds of questions to the ones we already worked on. You might get a question that says, are the lines through, we'll have some points here, negative 2, 5, and 1, negative 4, and 2, 4, negative 4, 1. Are the lines through those two pairs of points parallel? Perpendicular? Or neither? So again, this question is not asking us to draw a little graph and look at the lines and decide, do they look like they're parallel, do they look like they're perpendicular? What a question like this is asking us to do is compare slopes. So just like before, I'll call this line 1 and the second one line 2. Label my points x1, y1, x2, y2. Same thing for the second pair. And we're going to calculate our slopes. So for L1, the slope, y2 minus y1, negative 4 minus 5, over x2 minus x1, 1 minus negative 2. Negative 4 minus 5, we get negative 9. And 1 minus negative 2 is 3, which is negative 3. And we could think of it as negative 3 over 1. All right, so what would the slope of the second one have to be for these two lines to be parallel? That would be perpendicular. For them to be perpendicular, the slopes would have to be positive 1/3. But for them to be parallel, have to be the same, negative 3 over 1. So let's calculate. And if it's neither one of those, then the lines are neither parallel nor perpendicular. So for line 2, the slope, y2 minus y1, 1 minus 4, over x2 minus x1, negative 4 minus 2. 1 minus 4 is negative 3. 4 minus negative 2, negative 6. And this reduces to 1/2. 1/2, definitely not negative 3 over 1. 1/2 is not the negative reciprocal of this, not 1/3. So these lines are neither parallel nor perpendicular. So they're just two lines that eventually intersect somewhere. All right, questions there? Okay, the last example, similar to the second example we did with parallel lines. We want the equation of the line through six 2 perpendicular to y equals 3x plus 2. So same kind of question as last time. The last time we were asking about the parallel line. Now we want to know about the perpendicular line. So the slope of y equals 3x plus 2. What is that slope? 3. And I can think of it, if it helps, think of it as 3 over 1. So the slope of our new line, I'm going to say perpendicular line, is negative 1/3. We flip that fraction and change the sign. So there's our slope. This is my point, x1, y1. And I can write the equation, y minus y1 equals the slope, negative 1/3, x minus x1, x minus 6. That's fine for the equation of the line. You don't have to do anything else. We could rearrange this by distributing. And I get y minus 2 is negative 1/3 x. Negative 1/3 times negative 6 is positive 2. So we get y equals negative 1/3 x plus 4. And that would be our slope intercept, or our y equals mx plus b. Either one is fine. This one is easier to write because we have a point and a slope. All right, questions? Okay. There's that. Questions on any of the problems from last time? On page